Welcome and thank you, colleagues, for your time and attention. Today we'll be reviewing only one proposal that was sent to the NFPA today, but it's very large conceptually and will have significant effect upon the way we design and operate our building power systems. As always, these are our Friday afternoon updates. Are not polished presentations, but they're just intended to get the job done, which is to get ideas in front of these technical committees at a faster rate that they're coming at us. Of course, we fall far short of that, but at least we're on the track, or at least on the field of play. I should say we had a related discussion of this issue back in September, I think it was September 3rd, and we had Ohio State, Purdue University, University of Michigan, Ryan over at Oakland University, and Peter Basso Associates with us on that particular call. And we made good progress. There's a fair amount of depth in that discussion, and I think one of the more interesting outcomes was a recognition, and I'll give Ryan credit for this, that designers tend not to want to take exceptions. And what we accomplished in the NEC last revision cycle is that this got done. We did this. We took about 19 or 20 proposals. We managed to put data in front of the committee to convince them of the necessity to permit designers to use the actual load data to design their feeder and branch circuits. Remember that the National Electrical Code is a fire safety document, so the concern for energy conservation is not as high as fire safety. So we're trying to get some of that fixed, because our arguments were that if you're interested in fire safety, then you really don't want to have large incident energy. And this particular table is the culprit, or the origin, as to why lighting transformers, were 2 to 3 times larger than they needed to be. So we got this exception put in, and that was for 2014. So for this cycle, we're going to try to drive bright line concepts into this. So that will be the subject of today's teleconference, and we will work with the other table. I think we also said that we wanted to deal with outlet issues here. We believe that the default right here, 180 VA, oops, I missed it there, 180 VA per outlet, is likely the origin of some over-design also. Where's our 180 VA here, if I can find it? I just had it. To 2012. Let me search on 180. And wonderful, it's not giving it to me. Regardless, when a designer is putting together a power system, he has to allow so much power per outlet. Makes an assumption about how much they will be, how much power will be drawn from them, and how many of them will be used. And I believe that I might have logged out. I might have timed out on this particular issue. Let's see. No, I guess I'm still in. I'm dogged in my determination to get the section that I wanted to deal with, but will not. So we have a clear recognition about what we're going to be doing today. It's Article 220. This is the table we're working with, 220, 224, 2012, and we'll be working with the 180 VA. Here we go. Receptacle outlets. So, except as covered in any of these other sections, designers will calculate their outlet load at 180 VA for each single or each multiple receptacle on one yoke. So we believe that our data would show that this could taken down to 90 VA per outlet, but to be conservative, we'll scale into a 120 VA per outlet proposal that we may be able to back up with data. So I just spent more time than I wanted to on telling you what we're not going to do, and let's proceed over to what we're actually going to do. So let's look at this table. Let's look at what got submitted yesterday in paper form. I can find that for you. Here we go. What I'm trying to do here is to look at both the, I'll say the rows and the columns of this particular table. And note that I'm not going to drive and get into trying to deal with the banking industry or the barber shops or churches. I know a little something about the education industry, school buildings, and I know something about hospitals. And so for that reason, I'm going to confine proposals to only the facility classes that I know about, and now I know people who have data about. So here's the table as it stands right now. Here's the exception we got last time. Now we're going after the table itself. Now to do that, I'm working from the occupancy class. And as we look at the occupancy class, you'll begin to see that what I proposed here is that these new occupancy classes were added, and they originated in parts of the International Building Code. This actually I believe this should be the 2013 International Building Code. And you'll see that I've focused on assembly group, business group, educational group, institutional group for hospitals, for example, and residential group for student residence facilities. So that's the way IBC looks at it. And remember, their concern is for egress, getting people out of a building, among other things. That's a primary concern. And that's a fire safety that's an egress safety concern. It's possibly also a fire safety concern. There are other hazards within the building, but that tends to be the IBC preoccupation. Now, of course, ASHRAE 90.1, written and developed largely by the American Society of Heating and Refrigeration Engineers, have entered the lighting space. They feel that the lighting is within their purview, and they're undisputed in their control over and management of the concepts that flow through the lighting energy consumption space. So without getting too making too many political comments about that, what they're asking for example, hospital for office buildings, those organizations that want to conform to the ASHRAE requirement for lighting energy conservation in office buildings should not specify should have a lighting power density of 0.82. Of course, that's in a hospital, for example, 1.05. And of course, if you go up to the NEC table, that they couldn't be more divergent. So there's a 1/2 to a 1/3 difference between what ASHRAE permits you to conform to the energy code and what NFPA wants to see to meet its fire safety objectives. So what you're seeing me do here is work the rows and the columns, but I don't doubt that this will be a relatively contentious issue. So what I've stated here, I don't spend a lot of time trying to do the metric equivalence because I know that we're going to get pushback on this during the first part of the public input. But I do make clear it's a straw man proposal to expand the discussion about how this table, historically informed by fire safety considerations, should be modified to correlate with the IBC and the ASHRAE 90.1. So for the convenience of the committee, I've supplied them with all the information. We think that a task group, which we're proposing, and we would participate in that, could then formulate revisions that narrows the existing divergence among these different considerations. Probably one of the reasons why this divergence has existed for so long is that they simply couldn't see, the committees can't see what the others are doing. And this is an attempt to try to deal with that. And of course, we'll have to deal with copyright issues. I hope there won't be, because I'm not taking large parts, but I'm taking relevant parts of each of these documents. NEC committee can correlate them all. Finally, here I say from this, I'm not asking for 100% correlation, but I think we can have improved correlation between the three documents, and I'd be willing to lead that work groups within our industry, and possibly work with whatever data comes out of the NFPA Research Foundation project, which I've been trying to spearhead over the past couple of years. So that's the bulk of what I wanted to get across today. Remember that what I've done here is I've done it two ways. Oh, I didn't tell you about the electronic way, did I? Okay, so this is what it looks like using the new electronic format. Understand that because NFPA is making this transition to a new process, that you have the paper submittals, which were due yesterday. This was actually submitted yesterday. If I can show it to you, well, just take my word for it. It was submitted yesterday before the deadline. And now we have another month to use their electronic system. So the electronic system, you will see that this particular change was put in. I did that also, and you'll see the existing table. And I'm not going to make changes here. I've simply said replace the occupancy tables, replace that table with this one. And I feel that between the paper submittal and this electronic submittal, that I think the committee will get the point. So one of the advantages of working with the newer system, which we didn't have before, was that you can actually see what other people are submitting and proposing. What happened before is that the committees would see what happened, and the public couldn't see if there's other similar ideas that were being proposed by other experts or other interested parties and stakeholders. Here we can see that. Other people can now see what we've tried to do. I'm a little bit troubled by the fact that nobody else seems to be seeing this, but I've been down that road before. If you don't have a concern for this, it's probably nothing. It's a very it's a specialized area. There's not a lot of people. A lot of people are dealing with lighting circuits, but they're not leading. Far fewer are dealing with the lighting supply circuits. So it's probably some of the reason for that. So that's the advantage of the new NFPA electronic system. We're all struggling a little bit with it, but as I do it every time, I get a little bit better, and I see that we're likely to net. We would probably have a gain in our ability to run new ideas through the NEC. So I hope if others are interested in learning how to use it, I'm happy to help you. I believe Dan Brimmer is going to be using this, and a couple other of my colleagues who sat in on some of the other teleconferences will also be being the new system. We have a November 7th deadline to get some of the other ideas out there. So I guess we're getting close to what we're able to do for 1 week. Next week we will be working on what do we have scheduled for next week? It's going to be on demand. One of the reasons for that is that U of M has a guest coming in from the Washington office of the NEC. Actually, the CEO is visiting us, and we'll be developing a relationship there that should be fairly productive. And we believe that that will help us in the long run. So we'll be working with the committee chairmen at NSF that deals with the Safe Water Drinking Act. Some of the NSF standards inform the Safe Water Drinking Act. So while we may not be able to do anything about legislation that's already out there, it's important to just follow what's going on, because there's likely to be modifications to that. So you'll probably see that uploaded onto this site at this location sometime before next Friday. So with that, I think we've pretty much covered anything that's possible for this Friday afternoon, and I hope that everybody has a good weekend. And thank you very much for your time.